All right, when we are asked to find horizontal asymptotes of rational expressions, or really any expression, doesn't have to be rational, although we usually see rational ones like this. The idea is that the way you always find a horizontal asymptote is taking the limit to infinity and to negative infinity. For ones like this that are actually rational functions, meaning that the degree on top, meaning that, get the chair out of the way there, meaning that you have a polynomial on the top and the bottom, right? These are polynomials in x, meaning you have positive, or I should say non-negative integer powers of x. No fractions, no negatives, all that good stuff. So, in this case, you only really have to do the limit to infinity because the limit to negative infinity should do the same. Let's check. Limit as x goes to infinity of 2x squared plus x plus 1 over x cubed plus 7x minus 5. We can just say it's 0 because the degree on top is less than the degree on the bottom, but you also do the work of dividing everything by the highest power of x in the denominator. So if I do that, I'm actually going to, well, I'll do it and then I'm going to shortcut. So 2x squared over x cubed plus x over x cubed plus 1 over x cubed all over x cubed over x cubed 7x over x cubed minus 5 over x cubed. And then we simplify. So we get the limit as x goes to infinity of 2 over x plus 1 over x squared plus 1 over x cubed all over 1 plus 7 over x squared plus, minus 5 over x cubed. And we know that if x is going to infinity or negative infinity, anything that is being divided by x that's a constant over x or x squared or x cubed is going to go to 0. So that goes to 0, that goes to 0, that goes to 0, that goes to 0, that goes to 0. So you end up with 0 on top and 1 on the bottom. And 0 divided by any non-zero number is just 0. Right? 1 goes into 0 times. Be careful, I've seen people make a mistake here. Right? 0 over 1 or 0 divided by a non-zero number is 0. A number divided by 0, that's when it is undefined. Right? Dividing by 0 never works out. 0 divided by a number is super easy, right? What's 0 divided by 5? Well, 0 divided by 5 people, each person gets 0. Right? If you have 0 apples divided by 7 people, each person gets 0 apples. Okay, and then I'm not going to do it, but you can see here that if this had been the limit as x goes to negative infinity, you'd still do the same work, and you'd end up with still 0 because 2 divided by negative infinity still gets super duper small. So, whether you're going to positive or negative infinity, rational functions like this have the same limit. Here we could do the same thing. I actually don't want to do the work. I just want to say that the limit as x goes to infinity of 4x squared plus 7 over 9x squared plus 2x minus 8 is equal to 4 ninths because the degrees are the same. So what this means is for this first one over here, the horizontal asymptote is y equals 0. For the second one, the horizontal asymptote is y equal to 4 ninths. So whenever you find the limit to infinity, if it is a real number, so not infinity, not does not exist, if it's a real number, you get, that's what the horizontal asymptote is. On the other side of things here's a more challenging example. So in this case, when you have this weird square root of x squared kind of thing, you're almost always going to get a different limit to infinity than you get to minus infinity. So let's do the limit to infinity to find the horizontal asymptote. Oh, that's an interesting question, James. I didn't even think about that. So I decided I'm going to actually make this less terrible because the point of this, the point of this is a pain in the butt. I don't want the plus 3x here anymore. I thought I did, but it's kind of just makes it gross. I mean, we can do it with plus 3x, but it's, I want to show you this part of it, and then if you want more examples, let me know. So the idea here is that this is essentially x to the first on the bottom, and even though you don't exactly have an x to the first, it's still like x to the first. The square root of x squared kind of is like x to the first. So what we do for this is we factor out an x squared inside the square root. So pulling out an x squared or divide by x squared, I get 1 here and 6 over x there. Because if you distribute that back through, you get x squared times 1 is x squared. X squared times 6 over x is just 6 times x. Okay, but then we pull out the x squared, and this is where it's important. You get the limit as x goes to infinity of the square root of x squared, which is absolute value of x, times the square root of 1 plus 6 over x, all over 8x plus 7. In fact, up until this point, the work is the same whether it's the limit to infinity or negative infinity. So I'm actually going to write this, and then I'm going to write 2 different paths so I can fit this all in. So then, depending on what I do, so if I'm going to infinity, that means x is positive. So the absolute value of x is just x. If I'm going to minus infinity, then I get the limit as x goes to minus infinity. Well, if x is negative, the absolute value of x is negative x. But then for these, the work is still the same. Hopefully I think I can fill this in. Sorry, I know it's like not a lot of room. So what I'm going to do, now that I've got like x as the highest power on top and on the bottom, divide everything by x. It's going to be the limit as x goes to infinity of, if I divide everything by x, well, the top divided by x is just going to be the square root of 1 plus 6 over x. The bottom, if I divide each thing by x, I get 8 plus 7 over x. So then if I let x go to infinity, this part goes to 0, this part goes to 0, and I get the square root of 1, which is 1, over 8. Here, if I do the same work, I divide everything by x, I get the limit as x goes to minus infinity. Negative x divided by x is just negative 1, so negative 1 times the square root of 1 plus 6 over x. Again, I want to point out, I'm not dividing each of these parts by x because this is a product, and when you have a product of things divided by something, you just divide one part of it by x. Whereas here, this sum, each part of the sum gets divided by x. 8x divided by x is 8, 7 divided by x is 7 over x. And once again, we see that the things divided by x go to 0. So here I am getting negative 1 over 8. So the horizontal asymptotes would be y equal to positive 1/8 to the right when we go to infinity, and y equal to negative 1/8 to the left. No, they don't always end up being the opposites of each other. Like